Welcome to this tutorial. I'm solving question 9 of paper 2-2 May June exam series of 2022 in this tutorial. The topic of this question is radioactivity and half-life. The question says thorium-229 is a radioactive isotope used in several medical applications that involve alpha particles and beta particles. During ionization, a helium atom becomes a helium ion. Figure 9.1 shows a diagram of helium H positive ion. So in a helium, we can see that there are two protons, two neutrons, and one electron present in a helium ion, which shows that it has lost one of its electron. State how the structure of a helium atom differs from the structure of the helium ion. So in a helium atom, the neutral atom of helium, we have same number of electrons as protons, while in an ion we have lesser number of electrons than protons. State how the structure of an alpha particle differs from the structure of helium ion. So alpha particles, they are just like helium nuclei. Alpha particles, alpha particle has no electrons, while the helium ion that we were seeing has an electron. A nucleus of thorium decays by alpha emission to a nucleus of element X. The nucleus of X then decays to a nucleus of Y by beta emission. Now, the first equation is showing that an alpha emission is taking place. So, the proton number for X would be written by subtracting 2 from 90, and the nucleon number for X would be written by subtracting 4 from 229, so it would become 225, which means we are starting at 88 to 25. Then a beta decay occurs. So in a beta decay, we know that a neutron is going to convert itself into a proton and an electron. So the proton number is going to increase by 1, but the nucleon number would remain the same. So this is how we can complete the details. Now the next part is related to the same thing. They're saying complete table 9.1 to show the number of protons and neutrons in a nucleus of X and in a nucleus of Y. So the number of protons in a nucleus of X are 88 and in Y they are 89. For the number of neutrons, we would be subtracting the proton number from the nucleon number. Same is the case here. So here we have 137 and here we have 136. So the number of neutrons for X are 137 and for Y they are 136. Now the next part says experiments can show that a sample of a material is radioactive. Describe the apparatus and the procedure used to show that a sample emits both alpha particles and beta particles. You may draw a diagram of the apparatus if you wish. So the apparatus used would be a GM detector and a rate meter. So the method that we would follow for the experiment to prove that alpha and beta particles are being emitted is that a paper absorber would be placed between the source and the detector. If the count rate decreases, it shows that alpha particles are being emitted. The same could be checked for beta using a thin metal between the source and detector. So a rough diagram could be like this, that we would place a source over here. So this is the radioactive source. So the source is going to be placed in a lead box and it would be open from one side only. Now this source is going to emit radiations. So we are going to place a GM detector in front of it, and the distance would be less than 2 centimeters. Now this would be connected to a rate meter over here, and this would be showing us the reading of count rate, uh, maybe count per minute. So this is the GM tube, it is the rate meter. We have a lead box, and this is our radioactive source. This is an arrangement to investigate whether the radioactive substance is emitting alpha particles and beta particles or not. So for alpha particles, we would be placing a thick paper sheet between the source and the GM tube. If the count rate decreases, means alpha particles are being emitted. Similarly, we would place a thin metal between the source and the GM tube. Again, if the reading is decreasing, it means beta particles are being emitted during this emission. The next part says state what is meant by the half-life of thorium 229. So the definition of half-life is that it is the time taken for number of radioactive atoms to half. The next part says a sample of pure thorium contains 4.0 10 raised to 14 atoms. So these are the initial number of atoms. After 22,000 years, the number of atoms of thorium 229 in the sample is 5.0 10 raised to 13. Determine the half-life of thorium. So the starting number for thorium is 4.0 10 raised to 14. When it would be halved multiple times and 2 raised to the number of half-lives, the answer or the number of atoms would decrease to 5.0 10 raised to 13, which means 2 raised to n would be equal to 4.0 10 raised to 14 divided by 5.0 10 raised to 13. We would get an answer of 8 from here, which shows that 2 raised to n is equal to 2 raised to 3. So n would be equal to 3. We have 3 half-lives here. Now the value of half-life could be found using this relation, that the time is equal to number of half-lives multiplied by the half-life. So the half-life would be equal to time divided by the number of half-life. The time was 22,000 years and it would be divided by 3. So the answer is 733.33 years, and we would write this answer in two significant figure. So it would become 7,300 years, and this is the final answer for this part, 7,300 years. So the question ends here with this part.
We try to explain complex concepts in simple language and with effective examples. If you liked the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.